Before we start doing some of the classic recursion problems, we should do some of the problems from set 5, 6. I asked you to take a look at problems 1 through 13 and see if you can do the odd ones. I thought I'd try some of the even ones now so you can see the pattern. You have to be familiar with how the basic recursion formula works before you can do much of anything else. Here's problem number 2 in that section. It says b sub k is equal to the one before it plus 3k for all of the k's starting at 2. And we are given a seed of b sub 1 being equal to 1. Now all of these problems have the same instructions in that they're asking us to write the first 4 terms. Well, that's the first term. B sub 2 then is going to be b sub, well, it's the one before this, b sub 1 plus 3 times k, which is going to be 2. Well, b sub 1 you see is already 1. That was defined. That was our seed. So we're going to take 1, add 6, get 7. B sub 3 is going to be b sub 2 plus 3 times what? 3. It's going to be k. So b sub 2 is 7, and we're going to add 3 times 3, or 9 to that, and get 16. B sub 4 is equal to b sub 3 plus 3 times 4. So b sub 3 you see is 16. Then we're going to take the 3 times the 4 and get 12. 6 and 2 is 8. So this one is going to be 38. No, sorry. 6 and 2 is 8. 1 and 1 is 2. That's going to be 28.
Go to xfinity.com/prepare. Thank you.
Now let's take a look at number 4. Number 4 says d sub k is equal to k times the one before it squared, and we're going to start at 1. Our initial case here is d sub 0 is 3. So d sub 1 is going to equal, well, here k is 1. It's going to be 1 times d sub 0. Well, d sub 0 is 3. 1 times 3 squared is going to be 9. D sub 2, well, we're going to have 2 times d sub 1, which means it's going to be 2 times 9 squared. So this is 2 times 81, which is 162. D sub 3 is going to be 3 times d sub 2, which means it's going to be 3 times 162 squared. Hey, you see this one can get big very quickly. Okay, I pulled out my calculator, and this one goes to 78,732. Now let's look at number 6. In number 6, t sub k is equal to the one before it plus 2 times the one that is 2 before it. That's what our subscripts are indicating here. We're going to start this one at k being greater than 2, and it says t sub 0 is a negative 1, and t sub 1 is equal to 2 for our initial conditions. Now t2, you can see, is going to be put a 2 in for k, and you have 2 minus 1, which is 1, plus 2 times 2 minus 2 is 0. It's t sub 1 plus 2 times t sub 0. Well, t sub 1 we found is 2, and t sub 0 is negative 1. 2 times negative 1. Well, this is 2 plus a negative 2. So t sub 2 here is a 0. T sub 3 would then be t sub 2 plus 2 times t sub 1. Well, t sub 2 we just calculated to be a 0. And t sub 1 is 2, so we're going to take 2 times 2. This one's going to give us 4. This is a little different from the first group of these because this one is working with 2 initial cases, and it's looking back 2 previous conditions. You should try number 8 on your own and do all of the ones that are in the you should be able to do problems like section on the syllabus. Number 10 and the next ones like it are a little bit different because they give us an explicit formula. Here it says b sub n is equal to 4 to the nth power, and it says this explicit formula would be the formula for where n is equal to 0. What that explicit formula is saying is that b sub 0 is 4 to the 0. And we know anything to the 0th power is 1. B sub 1, it says, is then 4 to the 1st, which is 4. B sub 2 is going to be 4 squared, or 16. And you might notice that b sub 3, of course, is going to be 4 to the 3rd. So this is a sequence that you notice goes 1, 4, 16, 4 to the 3rd. This is a geometric sequence. But down here, what we want to see is what we can do to work with this recursively. If you see b sub k here, it says it's equal to 4 times b sub k minus 1. Alright, well when we do that, how does that work? We know that b sub k minus 1, using this kind of formula, is going to be 4 to the k. Well, it's not exactly 4 to the k, because you see this is starting at 1 and this is starting at 0, so it's really 4 to the k minus 1. Because when we do the 0th term, you see it's going to end up being 1. It's going to be 4 to the 0th power. So, when I take this times this, I have 4 with an exponent of 1, 4 with an exponent of k minus 1. Since the base is the same, when I multiply those together, I get 4 to the k, and lo and behold, that is our explicit formula. We've shown the two are the same. What we're going to do in some of these next problems is see how we can define something recursively, and in many cases we can come up with an explicit formula that would be able to make it go faster. And this can be very useful because if you could come up with an explicit formula, you can do things in one step with a routine instead of having a recursive routine.